Okay, let's see how many people we have here. Anyway, welcome to Python 100 week 6. We're almost halfway through the course. So today, the objective as outlined in my message is that we're going to continue with data cleaning, a little bit of kind of following from the last week. And also, if time permits, we are also going to see some of the sequels, which you are supposed to see next week and for the following. But I think it's helpful to have a little bit of preview on that because it's switching out of Python, say, in some sense. We're no longer working with pure Python. We're working with a slightly different language. And I mean, unfortunately, we don't really have a standalone SQL course, but SQL and database itself is worth like a whole year of like instruction in some places. Like you could start your whole career as a SQL database manager or administrator. And yeah, so we're just giving you a touch of that. But anyway, let's start up the session today with the warm-up question. Let me see if I can still no longer allowed to do this. Okay, I think this is all the options. So feel free to type your response in the chat. Maybe you haven't already seen this question if you've kind of cheated and just opened the notebook. But anyway, so we have this data frame here, just created, and we're interested in running one command like this. What would be the output of this line? A, something like this, nothing would happen. B, okay, we'll create something like this with the mean of A. That seems to make sense, right? Or nothing, it's just A. Or B. Raise an hand. Type your comment, type your answer in the chat, and we'll see. Okay, we see one answer for B. Anyone else? Anyone? What would be the best answer? B, A, C, D, or none of the above. If you think the answer is something else, feel free to type it. Only one answer. Welcome. If you're just joining, we're starting off with today's warm-up question. So basically, we were given this data frame, and we're trying to run this line, basically creating a new column for the mean of A. What would be the result of this line? Would it work as expected? Would it fail somehow? Feel free to type your response in the chat. Do everyone agree the answer is B? Type a +1 if you agree with the answer is B. Oh. No one? Come on, there has to be more than one answer for this. What will be the output? A, B, C, D, or something else? Make your best educated guess. No one else? A main adds the column. Yes. correct? Well, let's see, actually. Hold on a second. It's saying that function did not transform. What is wrong with this? This is actually a very subtle error that ChatGPT would not catch for you. If you're using ChatGPT for something like this, ChatGPT will tell you this is perfectly fine. Well, syntactically, this is perfectly fine, yes, but this line is wrong because transform will take in, well, so what's the shape of this df of A? It's a series of size 4, right? And when we're transforming something, the transform function, well, transform takes a function, mean will be a function, but that's not the main problem. The problem is transform will return something the same dimension as the first one. And by the same dimension, it would apply, but the problem is the average function will change the final dimension of A, of this series. I mean, if you take the average of this, you turn it from a 1x4 array into a 1x1 array, kind of. So most of the time when you're calling mean for transform, you'll get an error because you're changing the dimension of that. On the other hand, if you're calling it with apply, this will work. Because apply does not give you any restriction to the input and output dimension. It would just work. So it should be, one way you could do it is like this. This is working as expected. Or even simpler, you could just work A dot mean. This will work as well. Does that make sense? So this is a subtle part about apply, transform, and other stuff. It's about the dimension of items. So it's a subtle thing, but when you're, let's say it this way, you could do this operation. This thing will broadcast whatever is on the right-hand side to the left-hand side. Right? This is just as expected. We assign all of their value to 5. But the problem is, when you're calling transform, you're implicitly saying that, okay, this will give me a 1x4 array. But ultimately, that's not how it's supposed to work. So if you really want to, well, this is a terrible example of transform, but you can do transform. If you really want to use transform, you would have to use, hold on a second, function did not transform. Okay, yes, because it doesn't have a mean. Let's say x plus 1. This will work because this function is not changing the dimension of the input data. Okay? This function does not change the input of the data. If I just print it out, it will be like this. Whereas, if you're trying to change the input shape of the data, if your function will change the shape of the input, then your transform function will fail. And honestly, this is a terrible example because just for illustrative purpose. Because first, this is redundant. Second, it is not performing. If you really want to do this, you could just do like this. Okay? Any question for this so far? This is a common pitfall for transform. This is an error because mean will, the function mean will change the shape of the input. I mean, if you take it, you're calculating the mean of 1, 2, 3, and 4, your final output is a number. It's not 1, 2, 3, and 4 anymore. Transform, whatever comes into transform and out of transform need to have the same shape. Comes into and out of transform needs to have same shape. Okay, this may not seem super relevant here, but this will be a common problem as you're working with more complicated data and transformation. Cool. So that is one major difference of transform, apply versus broadcasting. Again, there's most of the time more than one ways to do the same like operation, but this one is a particular pitfall that a lot of people, including me, would follow when we first started. Okay, so today we're going to basically continue what we left off last time about data cleaning and validation. So here we do have a demo data set from Kaggle. I'm using Jupyter Notebook, but yeah, you could do this. You should be able to run the same thing in Jupyter Notebook and Kaggle Notebook. This data set is from Kaggle, just so you know. Okay, let's take a look at the data set. So this is about a long application. We have about 12 columns and around 600 counts in each column, roughly. Some of them have more NaN than the others. Some of them are just no NaN. Okay, so we have information about the gender, marital status, basically your basic information, your income, your co-applicant's income, etc., and your loan status, something like that. Basically, something you might be interested in evaluating if someone is a good candidate for a home loan. So we can also check out how many total like null values is here. By the way, I'm using null and NaN value like interchangeably. So this is just the basic information of this data. Cool. So first thing we could do, let's run a quick recap of the basic or of the most common data cleaning techniques we have. We have remove duplicates, which is basically like remove if two rows are completely identical. Or you could also specify, I'm only interested in the duplicates in these two columns. These two columns should not have any duplicates. Think about indexing or think about like their SSN. These columns are not supposed to have duplicates, right? And this function will just drop those entries with duplicates. Okay. At the same time, you could also drop NaN, which is kind of a common way you could do. This one will, the first line will drop all of the NaN value. Like if any of the thing in each of the row, for example, this one has one NaN, this one will be dropped. And if this one and this one are both NaN, then this row will also be dropped. That's how this drop Na in place would work. And the second way you can do is just about, okay, well, what if I'm only interested, I don't want to drop if there's any NaN. Some NaN are actually fine. For example, like for example, if the applicant has income and co-applicant does not have any income, I think that's fine, right? If applicant's income is large enough. Or for example, if the loan is NaN, but we're just evaluating a new loan, that's actually okay. So you could also specify which subset you're interested in dropping. And similarly, if you don't want to fill the NaN, just drop the NaN, you could fill them with whatever values you want. In principle, you're not supposed to drop it with unknown. Unknown is a string will take up the memory unless you really, really want to. And yeah, you could also do something like forward filling and backward filling. Notice that when you are setting up forward filling and backward filling, you will be reliant on your index. How forward filling and backward filling work is that, okay, there is an NaN value, I'm going to forward fill from the previous index. Hold up, there's no previous. Then what would happen? This will remain NaN. Okay? And backward filling will be, okay, I'm going to go down the next one and find the closest match. And if there is something out there, I'm going to use that value. That's backward filling. Notice that both of these techniques requires you to have a index. And you have more than one syntax to do forward filling and backward filling. This is equivalent. Cool. This is just syntax revision. All right. You can also just replace them with your custom records and so on and so forth. You can also chain your operations. This would do not try to do this in your first try. This will usually fail. You could, like, after you test it out, like, okay, all these operations will be valid, and you chain them together. But this is not something you should be aiming for when you were starting your assignment. Okay, so now let's see how we can actually move on and work with that. Let's
Hey,
review
David, I got
ourselves.
a question.
Yes.
So, sorry to interrupt. Is there a kind of a standard? Do I start with removing duplicates or do I start with handling missing values? What's the convention?
The answer is there's no convention depending on which data set you're looking at. I can give you like convention. Okay, you absolutely need to fill the duplicates value or absolutely need to fill the NaN value because what if your data has a lot of duplicates? Well, maybe removing the duplicates is the first thing you should do. Or can I just remove all the NaN values in the data set? Sometimes the answer is yes. We have like a 10% rule. For example, if less than 10% of the data is NaN, well, maybe drop NaN is just the easiest way if you don't care about it. But what if there's like, if you drop if you're SNA and you're having like 20% of your data, I think I can change
Yeah,
this.
right, right. Okay. Yeah.
I,
So like the rule of thumb that you have seen most often is that less than 10%. And it's just a rule of thumb, right? It's like,
yes, it really depends on what exactly you are working with. And
good.
in fact, in some of the data sets, NaN is a very valuable thing to look at because it usually indicates, okay, maybe there are some special conditions you will need to examine further, right? If something is NaN, something is off, then what exactly is off? And there, we're introducing the basic method, but there are other methods that allows you to fill in NaN more scientifically. For example, I don't think this is the thing. You feel free to dive into that. But one common way with advanced data science technique is that you can fill the NaN value with the closest neighbor, kind of an extension of k nearest neighbor method, where you're trying to situate the data, like basically you're kind of finding the closest match of the data point and use that to fill your NaN value. That is also an approach, like a common method to do that. But in principle,
Okay.
there's no
Thank you.
like standalone best practice for NaN value. It really depends on the quality of your data and what do you want to do with it.
Right. Okay. Thank you. Appreciate
Yeah. Okay. So as we said, the first way we could do is to just drop all the NaN value. Now this will do exactly like that. And as you can, and let's see how many counts do we have. We're kind of removing 20% of the data. This could be a little bit problematic, right? I dropped all the NaN value. Yes, now I don't have to worry about NaN causing like numeric error when I do division, something like that. But this is, I'm also losing 20% of the data set. Would this matter? Well, it depends really on your data set. If you have like 80 million data points and I'm losing 20% of the data, maybe that's okay. But be careful. This is also on the exploratory data analysis part. But what if a lot of those NAR are corresponding to a specific class of your people? For example, maybe well, this doesn't really work for this one. But what if instead of zero, there's a lot of co-applicant income as NaN, just because they don't really have any co-applicant? Do you really just drop all of this co-applicant income because they're NaN? That doesn't seem fair, right? Do we have, well, none of them are like, or what if you drop all of your information because their loan amount is zero, or they have no credit history? I think we dropped 10% of the data because they have no credit history. But is that fair? That doesn't seem like the best method we could do, right? So here, this error is intentional, as you can see. Instead of dropping all of the NAN value, I think we could do better than that just for this data set. So this is just some comments. This is where what we say like, in data science or data engineering, you always need a little bit of domain specific knowledge. You need to think about, have the common sense in this industry or about this data set so that you know what is a good approach to replace or fill in any value. So let's first draw the role if both long amount and long term are NAN. I mean, if their long term and long amount are both not there, well, then maybe we're missing too much information to evaluate this candidate. And if there is NAN in gender, I don't know, maybe for whatever reason they're not disclosing, or maybe they're non-binary people. Who knows? So let's just move them to non-disclose. I mean, it's also not fair to just drop a record just because this gender is missing, right? And I think the same thing could go for marital status. I mean, maybe some people are just not comfortable saying whether or not they're married for whatever reason. So instead of dropping them directly, let's put them into not disclosed. And finally, well, not finally, fill the NAN value in long amount term and long amount with the average of the column. Notice that you may say, hey, didn't we already drop that? Well, we dropped them when both of them are NAN. But if either of them is present, we're still interested in investigating the data. And also, if there's no records, if there's NAN in whether it's self-employed, then just put it as no. And if there's NAN in credit history, well, just put it as 0 for easier fix. This is completely a demo. Maybe in reality, this is not how you're like. If you're working a full-time job working like this is not a good approach. You will need to investigate further, like what exactly is causing this. But for now, let's just do it this way. And I'm trying to do it called a DF better drop. Hold on a second, there's a key error. Key error, gender and self-employed. What is wrong with this? Can anyone tell me how can I fix this? We've seen a very similar mistake, maybe one last week or 2 weeks ago. What is wrong with this? Key error? Aren't this all in the data sets? What's the key error coming from? Anyone? Where's this key error coming from? Any idea? I'll give a hint. Does fill NA work with a data frame or a series? And am I actually selecting a data frame or series? Okay, the series is popping up, but I'm not actually calling it. Is that a data is a series in the set of data frame? Yes, you're actually correct. If you're selecting this in this current format, your data frame is treating, okay, there is one of the labeling column. It's calling, your pandas is treating this as a label. Like there is a label that's named gender, comma, self-employee. But there's nothing like that because we're not selecting multiple columns into a new data frame. So the right way to do it is actually just selecting that as a data frame to fix the syntax error. And now we can call better drop. Okay, seems like we filled in some of the missing value. But that's just the first two steps. Okay, so now I'm going to send you guys into breakout rooms. So, and let you guys figure out how can we actually finish the remaining two steps. Okay, and yeah, we'll come back to discuss how it's all done. I think this is should be finished. We could finish this in maybe 5 or 10 minutes. Anyway, let me try to send you guys into breakout rooms systematically. Let's see. Okay. We're going to send you guys into breakout room, and I think we have two rooms, so each room will have someone explain how to do one of the tasks. Okay. We'll be back in about 5 or so minutes. If you haven't been into the breakout room, please join them. Okay, I think most people are back to the main room. So, can anyone tell me from, let's say, room one, tell me how do I fill the NaN with, in these two columns, with the average of the columns? Let's see. Anyone from room one? Let's say, correct me if I'm reading your name wrong. Harriet? Is that the right way to read it? Harriet, can you tell me how can I possibly do this one? Task 3. Fill the NaN in these two columns with the average of the column. Or correct me again. Yeah, anyone from room one. Hello?
Uh, Hi, I'm thinking about it. Well,
Any idea? Like, which function are we supposed to use?
I think the function fill in a
Fill in A, right?
yes, fill in the F yes that fill in yes that new column name.
Under a column
No,
A, yes.
yes, yeah,
So that would be long amount. The autocomplete is trying to finish that for me. Fill in A. What else do I need?
with the again DF better. Um,
It's already telling me. Next time I'll
yes,
turn off the
I think
auto.
this is
Next
what
time I'll turn off the
like
autocomplete function. But yeah, that's basically the case.
the the average of the two columns. Yeah.
I don't think it's necessary. I think you could just go with me here. Let me test
Mean
my
yes,
memory.
mean also.
Let me test my memory. Long amount. Okay, great. All right. Let's see someone from room two. Let's see how can we finish this last task. Anyone from room two?
No, David, I was hacking through it. I was AFK there for a minute and hacking through it, so
Okay.
I didn't get back. But I may say it wrong.
Okay.
Mang looks like he put a one in the chat there. He was in the room with us.
I see. Let's see if this will work. Long and mouse. Close. Close, but I don't. I think you could simplify this part a little bit, since that, well, if you're only working with one of the column, first, I don't think you're supposed to do the log operator with this like slicing. It might not give you an error, but I don't think it's a recommended approach. You could, and again, you don't really need this part. And I think this one will finish the one column. Well, we're filling the NA, right? Okay. We're going to fill the NA, right? So we're not supposed to drop it. But this one will fill. This one, after some minor correction, would work. And the second one, why am I copy pasting the same thing? The second one is that we need to fill in the long, that's a long amount, so we have the long amount term. Hold on a second. That's the last one. Self-employed. Oh, sorry, I was getting the wrong one. Self-employed. Is that how it's spelled? Yeah. You could, in principle, you could just also select one of them. It, this method here and this method here is the same. And the first argument here, it could be a function. It could also be just a value. It could also be a lambda function. So here we completed that, and we can see better drop. It's called better drop, but it's not supposed to be a drop all the way along. Let's see. Okay, it seems like we fill in most of that. Do we? Long amount. Somehow we're still having some NaN value here. Let's see. Da, da, da. Places was true. Okay, anyway, I think we need to copy this one. Then to actually change that. Oh, it's not filling in. Hold on a second. I think I missed one of the copy syntax. Equals to false. So on the slice, data frame, single terms, credit history, blah, blah. Still not right. Hold on a second. Let's do with this D. Wait, is it true? It's true. Something like this. Okay, so hold on. It's not the copy method. Something is wrong here. Drop NA, subset is this true, fill NA place is equal to true. Let's see. I don't think it should matter here. But anyway. Okay. Yes, now it does. Long and long term is not fully fixed. Okay. Seems like for this particular version of pandas, you might need to do this column by column. It's safer to do this one instead of doing it by multiple column. I think this will fix all of that. Huh, I didn't notice that. Yes. So, shove and a subset. Yeah. Okay. I think I might need to announce something here about the field NA because it does seems to depend on the version of pandas you're using. But in general, I think it's safer to fill in a column by column instead of selecting multiple columns and trying to fill them at the same time. Okay. So now we have filled in our table without losing much of the information. We're going to take a look at the head, and it seems to be, why is there still, oh, because we never fill in long amount? Oh, because I'm not printing out the better drop. Okay, we don't have any NAM value, and we're not missing any of the data. So this is supposedly a better approach than simply dropping everything. Any questions so far? Nope. Right. So in the remaining time today, we're going to do a quick preview of database and SQL. How many of you have worked with that before? Type +1 if you have worked with SQL already. Maybe in React class, maybe in web development class, something like that. Type a +1 if you have worked with that before. No one? Okay. So let's try to do a quick, brief introduction to SQL. So SQL stands for Standard Querying Language. It is a declarative language designed for database management, transformation, and of course, query data. What do we mean by declarative language? Well, previously, in most of the programming language we've used so far, well, if I write this line, this line will be executed like line by line by the computer, right? Python will execute this first line and the second line and this first one and the second one. This is what we call imperative language. The computer will do exactly what you tell it to do. For declarative language, including SQL and other functional programming languages, for example, Scala maybe, what are other ones? Haskell, if you have the pleasure to work with them. For declarative language, yours, like the sequence of your code, is not perfectly the same as the sequence that your code is executed. Which is to say that, sometimes you will have to write a code in a slightly different mindset. And back deep in the hook, most of the SQL has its own like query engine that will try to optimize a query plan for your query. Which is to say, okay, if you ask SQL, okay, I want to fetch this data from this 2, 3, 4 different tables, the SQL engine will try to find the best way to do that instead of doing exactly what you tell it to do. This is good in terms of performance, but it's also dangerous because you might get something you are not expecting. But for our purpose, it doesn't really matter that much. unless you're super performance critical. And maybe some of you have heard about different flavors or different dialects of SQL, MySQL, PostgreSQL, SQL DB, Transact SQL, SQL Server, something like that. Well, most of they do have tiny differences, and depending on which environment you're using, you might be using MySQL, you might be using PostgreSQL. They require different setup, yes, but there's only a really minor difference in the basic syntax. Like what we have covered today will work in general across most of the SQL flavor. Most of them have the standard syntax. And yes, there are some functions that only works in one of the SQL language, but not the other ones. Or sometimes there's something that's worked differently, but we don't really need to worry about that much here, unless you want to be a dedicated database administrator or a data engineer. Okay, so why do we need SQL? Do we already have pandas? Like pandas can already do like querying for us. We can already do data engineering with pandas. Why do we need SQL? Well, here's the thing. Panda are great for small-scale analysis, but it couldn't handle transaction consistency and isolation of database very well. Think about this. If you're building a web application that have two users trying to update the data at the same time, how would pandas do that? Well, it might become ambiguous and you might have some trouble with that because Panda is not designed to handle multiple requests at the same time. On the other hand, most of the SQL databases are designed to handle this. So if you're ever building like a web application that really need a database, SQL is usually the go-to option. And SQLite is probably the easiest one to start with. And even for larger scale analytics, well, pandas only work for small scale analysis. I already say it multiple times. You can give it a try, but pandas will start failing when your data set is on the scale of gigabytes. Maybe I think for most personal computer, 1 GB is enough to crash your pandas. Believe me or not, 1 GB is enough to crash your computer. But for a lot of the modern data engineering stuff, we're handling requests on this or data query on a scale of petabytes, terabytes. How can we handle that? Well, that's when you might need to go beyond your personal computer. You might need to go to cloud computing and so on and so forth. And that is also when you might start working with like tools that's developed around SQL and used to handle analysis. Okay? Okay, I think I'm actually going to delete this line because I have the demo below. So there are 4 components of basic SQL commands. It's called CRUD. It's actually the same thing as most of the common like backend operation. You have the create operation, the read operation, the update operation, and delete operation. So this, well, actually I'm not using DocDB this time. I'm using SQLite. Why am I including that? Okay. So this cell is just for executing the SQL in like the cell. It's not related to any of the tasks. You don't really need to know what's happening. So now I'm using DemoDB here. I can create a table like this, just like creating a table in Pandas, or I can also read something from here. But this one is just, okay, this is the name, and this one is the integer. You don't really need to worry about what is the primary key for now. The second one is the name of this column, naming column, and the third column is department, and the fourth column is salary. We are also specifying the data type. In principle, I don't think you need to specify the data type for every SQL, depending on which SQL you're using. And now we're just inserting 2 rows into this database, well, into this table, not this database. So a database can contain multiple different tables. So we're creating a new table in this demo.db database. And this new table is called employees. And here we are inserting 2 rows into this. So far, so good. Now we can select star, we'll select everything from this employees. And in principle, it's not a very efficient approach, but since we only have 2 data, I can also use limit 1 so that I only want to see one record. It doesn't really matter here. Okay, and now I can also specify which columns I want to see. If I only want to see the name, then I have Alice. And if I only want to see the, let's say, what else do we have? Department. I can also do this. You always select something from your table. So far, so good. This is a little bit more natural than pandas in some sense. Now, I can also filter my data with where clause. If I only want to see people in HR department, I can do this. If I only want to see people in the IT department, I can do this. I can also do it on condition. For example, I can do it where their salary is greater than 60,000, for example. Cool. Okay. I can also sort my data with an order by statement. And this is where things getting trickier. We have aggregation. Notice that, hey, average of salary. Do we say it's trickier? We're selecting a department and the average salary across the department from this table grew by department, right? Why do we say it's getting tricky here? Because, okay, what if I am interested in something like the average salary? I already have this average salary here, right? Can I run this one? Can I? Well, I guess if I'm asking this, the answer is no. Why? Don't I already have this average salary? Well, this is why we say SQL is declarative, because by the time for the actual queries, like in the actual query plan, the where clause is actually executed before the aggregation clause. Where is executed before group by. But your average salary is only available after you run the group by statement. So this is when you need to modify it into use having. This is one common caveat in SQL. I know you don't need this for this week's assignment, but this will save you some time for your next week's assignments. And you could also do something like update and so on and so forth, like that. Feel free to play with this notebook. You could do this like magic book with that. And you could also just delete the entire table. Now, I can also kind of convert from pandas data frame to SQL and load my entire data frame into this and do similar operations as above. One way to kind of learn SQL is, I would suggest this as an extended exercise. This might take you a lot of time, but I think it's worth it. Try to do all of these like fill NA operations in SQL, and you'll learn a lot about how do you actually do something like that. You will also learn things about coalesce and something about join, about something like that. It's a little bit more involved for that, but if you really want to work with SQLs, you should be able to do all of the operations we've seen above so far in pandas with SQL. Okay, so that's a quick overview of SQL. Hopefully you can start playing around with that. Working with this notebook is probably easier than setting up your own database on your command line. So yeah, feel free to let me know if you have any other questions. I'll hang here a bit for a little bit. But yeah, I think that's all I want to cover for this week. Stop share. Feel free to let me know if you have any other questions. Thanks for coming. And yeah, hopefully you're having fun for this week's assignment and maybe next week's assignment too. I'll hang here for a few more seconds if you have any questions.
Thank you.
Yeah.